Oh, hey, where did the middle sections go?
We'll get to those in a second.
All right.
Don't worry, like next week or something.
Okay, or something. I like it. Modeling with functions.
Okay, so
sounds like word problems.
It is word problems.
I don't like word problems.
Well, you really.
I mean, do we have to do the word problems?
We do have to do. We have to do the word problems because whenever you're like, man, where am I ever going to use math in real life?
Like when I buy a new car.
Or, yeah, things like that. Like
get a house.
Word problems have kind of to do with that. That's where we're going to find our applications to real life. So we've got to learn how to do them. So first, let's start with some simple translation.
Okay, let's do it.
Because all you have to do when you've got words and you're trying to do something with math is just translate it. It's like a different language in a way.
Right.
And here's a big one.
The more you use it, the easier it gets.
Yeah. Here's a big one. More than.
More than. That means after.
Yes.
Like you are more than something. You are after something.
So 5 more than a number x means that I want to do x plus 5. Now, technically, that's the same as 5 plus x.
Right, because the addition symbol is commutative.
Right, but less than...
Oh, that's...
If you don't do minus whatever, then you've screwed everything up.
Minus hashtag oops. Yeah, indeed. So anytime more than, less than means it happens after...
Yes, after. Yeah.
After.
Okay, so let's try this. Double, any other one, though, means to go in that order.
Yeah, go in order. Okay.
So double a number increased by 7.
Oh, that's going to be 2x plus 7.
Okay.
Because we're doubling a number, increasing it by 7. Bam!
Okay. A salary x after a 10% increase would be?
That would be x.
Okay.
Plus, I guess it would be what, 0.01x?
0.1x.
Yeah. Oh, yeah, 0.1x. Yes.
Okay.
Yes.
So what's happening is that you have the salary, you're taking 10% of that amount, and you're adding it to the original amount. So that's what we've got
That's an
right now.
important real life situation. Like if somebody offered you a 10% increase in pay, you would want to know what that would be.
Right. That has to do with salaries. You also see that kind of a thing a lot with price markups or in the next one, a sale. Now, you could write this x plus 0.1x as 1.1x, where the 1 is...
Yes, you could.
The 1 is your original salary, and the 0.1 is the 10% increase. So, if it's on sale...
Oh, if it's on sale.
So we're taking x and we're subtracting that discount, which is 0.25 of our amount.
Right.
And so that ends up being
0.75x. So you could use both of those.
And hopefully that's something that if you don't already use in your real life shopping experiences that you can come to do. Like when you see that
25% off something at the Buckle.
You just take out your calculator and do 0.75 times.
You don't even need to take out your calculator. Just you take out your phone.
That's what I meant. I meant the calculator on your phone.
Yeah, okay, all right.
But yeah. The cost of a cell phone plan each month that has a base charge of $40 plus $20 for each gigabyte of data used. You know, that almost sounds like a real thing.
I feel like that might actually be our actual plan. Did you look at my cell phone bill last month?
No.
I feel like...
you don't even get a gig, do you? Have like 256 megabytes?
We upgraded.
Oh, yeah. Good job.
To 2 gigabytes.
To 2 gigabytes. Congrats.
Yeah.
Okay. So every month you're going to get charged $40.
Plus
$20 times every gigabyte that you use.
Which in this case would be X. Because if you don't go over the gigabyte, you put a big old 0 in there.
Well, if you use 1 gigabyte.
Right. Or large or more.
But
right. But if you don't use that gigabyte, like if you use half a gigabyte, you use 0 gigabytes, so it's just a $40 bill. But if you use 1 gigabyte, then it's 40 plus 20.
Gotcha. Okay, I gotcha.
And this one is really similar to actually the step function.
Yes.
That's all cell phone bills are set up according to the step function.
Because you either pay this or this.
You move up to the next level.
This.
Yeah, there's no in-betweenies.
Yeah. So from 0 to 1 gig, this is how much you're paying, and from 1 gig to 2 gig, and so on.
And we're going to talk about those later.
Yes.
Indeed.
All right.
Let's get some functions rolling.
Yeah, let's. So when a problem says write y as a function of x, it wants you to write a formula.
Y?
That like y and x are things. Like it could be something else.
Y?
No, stop.
Oh.
Okay. The point is, if it says write something as a function of something else, it wants you to write a formula that's solved for the first thing.
Right.
And only has
the other
thing on the right side.
Right.
So on example 2, we're going to work with the area of a circle.
Yeah, let's do.
Which is
pi r squared. A equals pi r squared. That's the area of a circle right there.
And we're writing it. We're writing area as a function of its radius,
which is a as a function of r.
As a function of r, which we actually have.
Right.
Because pi is a number.
Right.
Not
Pi is
a
a
variable.
number. That is correct. And you'll forget that later this year, and I don't know why you'll forget that, but you will.
But just remember, pi is a number.
Yeah.
So it's okay. Now, if we want to write the area of a circle as a function of its diameter.
Oh boy.
Now let's think about the connection that we have here. Can't we equate something with the radius and the diameter?
Yes, we can.
How many radiuses?
There are 2 radiuses for every 1 diameter.
Okay. But in our formula here, we've got r. And so we want to plug in r. So we need to solve this.
So look at that, half a d.
R equals half a d. So we're going to take what the formula normally is, but instead of
squared. Oh, I know. You're going to put 1/2 d, close parentheses, and square that puppy.
Yes.
Now we could be, okay, you could be really uber nerdy.
Or awesome.
Or awesome.
Because I think that's...
some of us know where we belong.
Yeah.
This would be 4 on the denominator.
Right.
Okay, so to
1/2 squared would be 1/4.
1/4. So you could do this. You could do pi d over 4. How about that? D squared, of course.
Oh yeah. What the whole point of that is the squared goes to both of these.
Right.
So a half squared is a 4th.
Right.
D squared is d squared. Pi's still in front, and it still equals a.
Right. Or if you wanted to, you could simply have.
You could write
a variety
lots of ways. 1/4 pi
d squared.
Honestly, I think that probably looks the neatest personally.
Cramming it all together though. Come on.
Yeah, well.
All right.
Now this one's tricky.
The circumference.
C.
That looks tough.
So we're trying to. Let me switch colors. Yeah. We're trying to write a equals pi r squared, but we don't want r. We want c for circumference. Okay. What is the formula for circumference?
2 pi r.
So that means we want to be able to put c in here.
Yep, so we're going to have to solve that puppy for r.
Tricky.
It's tricksy.
So r equals c over 2 pi. We're going to put that right where that r is.
So it's going to be, can you see that?
I can see that.
Okay. The students may not. That's a little better. I like that color.
Equals pi, and in parentheses.
C over 2 pi squared. Now, I love how this one looks when it's, well, the pi's canceled out, sort of.
But see, everything in parentheses has to get squared, right?
So pi actually gets a square on it. So c squared over 4 pi squared. And
so a pi cancels out.
Right.
But we're still left with a pi
Still left with a pi. So you got c squared over 4 pi's. I love pies.
Are you talking about
chocolate pies, cherry pies, pumpkin pies, apple pies?
The whole point, though, is that
eating some pie.
We wrote area as a function of the circumference. So a was on the left, c was on the right.
Right.
No other variables were involved.
Correct.
Or harmed in the making.
That is correct. This was variable safe production.
Yes.
Yes. General PSSs.
Problem-solving strategies. So,
It's
depending...
like ROUSSs.
The rodents of unusual
size.
Yes. Yeah, from The Princess Bride.
Indeed.
Good times. Okay, so you can draw a picture.
Almost always beneficial.
Yeah. You can represent an unknown quantity with a variable and use that to create an equation to solve. That's super helpful.
Also very helpful.
Unfortunately, or fortunately, depending on your opinion, a lot of times this requires real-world knowledge.
So when you say
like
real
fact
world,
that if you decrease a price, it gets smaller. Things that make sense to us.
Okay.
And so we'll throw out a few things here that you should know, but maybe you don't know.
Okay. All right. Sounds good.
Well, on this first one, we have 3 consecutive odd numbers that add up to be 249. So we want to write an equation and find the 3 numbers. Now, we could guess and check. But
Yeah,
that
but
could
there's-
potentially take a while.
There's a lot of odd numbers out there.
There are.
And like 1 plus 3 plus 5, that doesn't.
Yeah.
So
You could
one-
sit there and do that for a while.
so 3
now,
plus
I know,
5
though, that
plus
there are
7,
some people watching this that are, or not watching this, that are
5
smart.
plus 7 plus 9.
Okay, our first odd number. Why don't we represent
1.
it with x?
Oh, x.
What would that make our next odd number?
X plus 3, because it's got to be odd.
X plus 3?
Yeah, because
Okay.
3 is odd, right?
If this is x, how much do I have to add to get to the next odd number?
2.
So our next odd number has to be whatever x is plus 2.
But 2's even.
But odd numbers are 2 apart.
Okay. All right, I
Okay.
like it. So the next one could be x plus 2 plus 2.
Which is x plus 4.
All right.
So we've represented our first, our second, and our third odd number, and these all have to...
Sum up to be 249. So add those bad boys together and set it equal.
Now, what we did here is we used an example like 1, 3, and 5 that we knew wouldn't work, but
Right.
to help us come up with what's happening between these.
That's the real world knowledge part. Like, instinct says you want to have odd numbers all over the place here,
Right.
but that's not true when you're trying to find consecutive odd numbers.
They're
so
2
if
apart.
you can write them out, 1, 3, and 5, you see that and you go, oh, they're 2 apart, no problem.
Right. So we have
3 x's
Yep, 3x.
and a 6.
Plus 6 equals 249. Simple two-step equation, subtract 6 over, and then divide by 3. You're not reaching for the calculator, so I guess you...
81, baby.
Oh, wow.
That's the first one, and it's odd.
So, that's good. So our first one is 81. It
That's
asks
good
us
that
for
I
all
got it
three.
without the calculator?
Yes, it is.
Yes.
What's next after 81?
Plus 2 is 83.
And then?
Plus 2 is 85. So there you go. 3 consecutive odd babies.
Real world
Mistakes.
knowledge. There's a formula that says that distance equals rate times time.
I thought that says rate x time.
Well, I used like an old-fashioned x for
For
multiplication.
rate cross time.
Rate times time.
Okay.
So this is true like when you're in your car and you're going 70 miles per hour and you do that for 2 hours, you should go 140 miles.
So this is like that video where the
girl
and the guy are traveling, and he goes, if you go 60 miles an hour, how far do you go in 1 hour?
and she's like, you just cut it in
she-
half.
Yeah, she has a hard time.
That's a great video.
Yeah, it's pretty funny. Maybe we'll link it.
Okay, so this problem, though, is a pretty simple problem, and you'll see them get a little bit more complex than this, but it says a traveling salesperson averaged 42 miles per hour on a 215-mile trip. How many hours were spent on the trip? So
we've got a rate, and we have a distance. So we don't have a time.
And that's what we're going to solve for. So D equals R T.
Times T. Oh boy.
Solve it up.
This one I'm going to just
You
real
just
quick.
cut it in half.
Just cut it. And just the tires, or you got to figure out how tall the tires are. 5.119 hours.
5.119 hours. That's all there is to
Boom.
that.
Oh boy, Swine Week. Now, if you're not familiar with Edmund Memorial, Swine Week is
Amazing.
Yeah, and
Phenomenal.
right, and teachers I think loathe and love Swine Week all the same
It's
time.
a love-hate relationship,
Yeah.
I think, for everyone, and it really just depends on the day of the week or the hour of the day or whatever. But overall, it's a great thing.
It's a pretty amazing thing what the students do. So this is real life numbers. For those of you that don't go to our school, this is what we do in 1 week.
Yeah, it's actually
A little
almost
more
the
than
whole
that.
year
Well, yeah.
in the process. But we're going to use this data for finding percentage increase. So this is when you have an amount, you have a new amount, and you want to know what percent did it increase.
Right.
So you do the stopping amount minus the starting amount divided by the starting amount.
Right. And
So-
that gets you your percent.
So the starting amount here is our 2013 data,
Mm-hmm.
and the stopping amount is our 2014 data.
Right.
And so we're just going to subtract.
The stop minus start. And this is actually something that will come in handy a lot this year, and especially next year in calculus. Is if
Typically,
you can get your stop minus starts, if you know what those are, that can eliminate a lot of potential headaches.
very rarely do we do start minus stop. That just doesn't ever That's never a thing. It just doesn't seem like it. Now this
88,511 on the top.
88,511 on the top. And then when you're doing this, either press enter like Mr. Hazelwood did, or put the top in parentheses and then divide the bottom. And we'll get a nice decimal, 0.2507. And we want to change it to a percent, so that's 25.07%. So between 2013 and 2014, we had a 25% increase in how much we raised. So that is significant.
That's significant indeed. Solutions, mixtures, those darn chemistry things.
They are not just in, well, I guess it's mostly chemical things, but like alloys, where you have
I don't even know what you just said just
gold
now. So.
Mixed with something else. Anytime you have a percentage of something, you typically have something like this. This is the case where you have two things you're putting together into one thing. The important thing to realize is that if you got a percent times an amount plus a percent times an amount, it equals a percent times an amount.
Right.
And
the unit has to stay the same the whole way through.
Right.
That's the important thing.
So on this example, Ted wants to make 10 liters of a 29% saline solution by mixing together a 15% saline solution and an 85% saline solution. So how much of each must he use? We want to make basically this formula.
We know that he wants 10 liters of 29%, so that's on the right-hand side of the equal sign.
Indeed. Now, we don't know either of these two amounts, but we do know that they have to add up to be 10.
Right.
So one of the amounts we could call x.
And the other amount we could call 10 minus x.
Right.
And it doesn't matter which one's which.
Right. Either way, we'll end up being able to figure out both of them.
Right.
And there are a couple other ways you could do this. The way we're doing this is helping us to avoid a system of equations.
Right. Right.
Just because we haven't talked about that yet, and we won't really talk about systems for a while. But this is, if you can do this, these two things, x plus 10 minus x, that should add up to be 10.
Right.
And then
well, and if you're a whiz bang with a system already, and
then
you're
by all means,
if you're a chemistry nerd and this is old info to you, by all means, as long as the math is correct, we don't care how you do it. But math
needs to happen.
Math needs to happen correctly.
So I'm just sitting here distributing.
Math. You can't create math.
Things do not just randomly come out of nowhere.
Right.
Oh, I can do this. 0.29 times 10 is 2.9.
2.9 there, Mrs. K. Steve.
Okay, I distributed on this right here and multiplied that out. Now we want our x's together and our numbers together. 0.15x minus 0.85x.
I believe that's negative 0.7.
Yep. And let's subtract 8.5.
Oh, that's a little trickier. Negative 5.6. Now, here's where you'll know if you've set it up correctly or not.
Because when we divide, they're
both negatives. So if you wind up with one positive, one negative, we're not going to add a negative amount of solution.
Because you can't.
Can't do that. So no.
So this looks like a 8 to me.
I believe it is an 8.
So we will have 8 liters.
Yes.
Of the 15%.
And why do we know it's 15%? Because that's where the x is. And that means we're going to have 2 liters of the 85%.
And this is the way we would want you to write that out, to actually specify. It doesn't really, it's not super helpful for you to say, oh, 8.
Yeah, 8. I got 8.
I got 8.
Hey, me too.
Did you get 8?
I got 8.
I got 8. We got 8.
I got 8 17 times.
But it's better if you tell us 8 of what.
Right.
And then what is the other thing? 2 of that.
Right. So. We need all the info.
Now,
oh yeah, we can.
Code word for this video is going to be, it's all the way back from the first example where we said minus hashtag oops. If you'll just type that in on the assignment on Edmodo, that's our code word for section 1.7.
This is beneficial.
Code words are good. Put that in. Don't tell your friends. Let them find it for themselves.
That's right.